Hello everybody. I think I've got a really good presentation for you today concerning ducted fans and different configurations, and just lots of information to share with you. Hope you enjoy the show. Sit back, get you a cup of coffee, and just take you a break, and share in the fun of what I'm doing. My commitment for 2021 is to made in the USA 100%. Okay, and there's some situations not going to be able to do that. It's just because the raw commodities aren't available in the United States, and so but we're shifting. Lots of things are changing because of the China virus, and the getting that all set up to where designing and engineering things to be 100% made in the USA. But I have that commitment. I want to do that. With batteries, because the lead in the United States is quite a bit different. It's hard to buy lead in the United States at commodity pricing. So that's one thing that I want to buy it, and I want it to be competitive, but the commodity conversion with labor, we're just not set up for it yet. So, I mean, you can't be an idiot and make it cost too much. So any areas that you can help me out with manufacturing of units, please direct me that way. So I want to give you a progress report. This is actually for yesterday, Friday, January 1st, 2021, but I do not work a lick. I might play, but I don't work a lick on January 1st. It's kind of an old superstition, but I ate my black-eyed peas and my cabbage, and I put my number 8 in my billfold. And actually, I put the number 9 in my billfold. I used to put the number 8, and I put the number 9. I've changed the superstition up just a little bit. So anyway, I hope you like my new format. It's I plan to one day click through the videos. I've got to get the audio thing set up to do that. Making videos has just never been my forte, but in today's world, if people don't see what you're doing, they don't believe it. Okay, and so anyway, I've made a commitment this year to do updates with video, what we're working on and the progress, and we'll track it and see how it goes over 2021. I've tried it before, and I just get too busy to make videos, and it's like a waste of time in some areas, but I think it's more important to do those things. So anyway, let's jump into it, and it's not all about Legioneering. It's not about me. I call everybody out there in the work field a Legionnaire, and we Legioneering together, and that's the reason I named what I do Legioneering over 5 years ago, because I used American Legion help to do different projects. Guys that are retired military, very smart, very well trained people, and learned a lot, and we're doing that. One of the things I want to throw out to you, and I hope you can see it because I can't see it on the video as well, but the control line flying was a big part of my life when I was a youngster, and there's things from these days, from just going around a circle, that I really did learn, and I learned asymmetrical in the symmetrical world back in those days. And so people look at my aircraft and they go, well, the wings aren't straight, and yeah, they just thought it was just a goofy kid putting something together, and I just kind of went along with that. But depending on how this video comes out, what we're seeing, it's kind of bright in here. Right now, I don't know if the camera's adjusting to it or not, so we'll just see how it comes out. Took down all my Christmas lights on the outside, and it's a nice day outside, warmed up. We had lots of moisture yesterday, but now it's bright and clear in my neck of the woods. Anyway, I want to plant that seed, building models and control line flying. Studying the Osprey, want to give some clues about what we're doing with the Manta and the electric Manta control line competition. Not really interested in the vertical takeoff and landing part of that. Setting up for learning in the control line system. There's advantages there, trust me, building the model, but the military did such a good job putting the Osprey together, and they had NVG night vision goggle compatible instrument panels built into the system. Systems fly by wire, plenty of power to do lots of things. Want to get into ducted fan technology, and with the 10-inch blades on a 2-blade system, they produce about 16.08 pounds of thrust at 24,074 RPM. Okay, you up that to a 3-blade, and guess what? You up that number by 50%. But then, when you I said 50%, 40%. And then when you up that to the 4-bladed system, you increase your torque, but your on your 4th blade, you only have an increase of 47% in a symmetrical system. Now, keep in mind that everything that I like to do, I hunt the asymmetrical, and I call it metronomic system, and there's things that you can do in that area. People always ask me, why I'm always playing with my wheel and putting different things on it, and playing with asymmetrical. The wheel just teaches you so much how to line things up. It's one of my great slide rules, okay? And the 3-bladed prop is to me, from the micro scale to the macro scale, and we're going to talk about other things, but the 3-bladed prop to me is really efficient, okay? You'll find that if you're dealing with odd number props, okay, a 1-bladed prop is smoother than a 2-bladed prop. A 3-bladed prop is smoother than a 2-bladed prop, okay? 4-bladed prop is not as smooth as a 5-bladed prop, okay? And the 6-bladed prop is not as smooth as a 7-bladed prop. And the 9-bladed prop is smoother all the way around, and there's things with the system. I'll show you the SOS prop that we originally came up with, and why it's called the SOS prop, because when you listen to it, it sounds like SOS, okay, in high-speed configuration. So I hope you enjoy the show, but we're going to talk about the ducted fan. Clearances have to be really close in your duct, and there's things within the tube that you can do, but the whole idea is that you want to create suction to get your thrust. And there's an effect called the Condell effect, and you pick up extra thrust by going over that airfoil because you're accelerating the mass over the top, and so that pulls it up. If I take a piece of paper and have it smooth enough, I can actually blow over the top piece of paper and it'll pull it up, and that's part of Bernoulli's force, and that's modified in the duct system. Two-bladed prop is not as efficient. I mean, as far as giving you airspeed, that's fine, but you're not going to get as much thrust out of a two-bladed prop as you are with a three-bladed prop. And we'll show you more of that and get into more of that part of the detail as we go through. Now you can see the Osprey has very large propellers, but I want you to notice, remember the rooster tail I was telling you about? The Osprey takes advantage of several things within the system, and that's an open air prop, and it's actually a tractor configuration. The ducted fans, most of the ducted fans are tractor configuration, okay? And there's a, for rear jet propulsion, I like pusher, okay? And the same theory works with everything from watercraft, and there are some differences, but I've always been able to get more speed from a pusher prop than I have from a puller prop, okay? But there are advantages to having the puller configuration with watercraft. So some more things I got to find out and study in that area as R&D. The Coanda effect is where you're following the shape of what's out there with fluid dynamics, and it adheres to the surface, and the flowing fluid are directed by the curving surfaces. Works with water, works with air. If you think of air, air is a fluid. It's not as dense as water. You can compress air, but you can't compress water. So but you remember the rooster tail? With a pusher prop, we're riding the prop on the hard water, and with the Coanda effect, you can actually compress the air in a pulse in front of it to set it up from suction to bring it in where you even have an advantage in doing that. And I'm all about harnessing the Coanda effect, and you'll see how it's done through the industry. Well, remember a single blade prop? Okay, that takes the least torque to turn. Okay, and it's not articulating. There is a version that was made for aircraft, and I haven't been able to find it, but it was an articulating prop. In other words, as it turned, it articulated at the blade, but this is non-articulating. But you'll notice this bulge right here. Well, that bulge sets up the Coanda effect, and I like harnessing the Coanda effect. Been harnessing the Coanda effect with watercraft for a long time in design and features. This is the Everil prop, and single blade prop. It's not articulating, but it's set up to take care of that, and that little foil on there is what does that. If it doesn't have that foil on that side of the prop on the tractor configuration, it does work, but it's not as efficient. Of course, you do have weighted to balance the prop, but believe it or not, a one-bladed prop design is the most efficient. It just doesn't move as much thrust, okay? But you can speed it up, and there's advantages to it, okay? And same time deal, this one is missing the leaded surface on it, but that's the Everal, and I love old newspapers and things because they showed how that was done back in the day. The three-bladed ducted water propeller, and I know a whole lot about this, but you'll see on this design for the jet ski that it has a little foil on front of it, and then the bottom blade articulates, and it stepped a third through the system. So they harness that effect, and it sets up a rooster tail I call it the rooster tail effect, that catches a compressed pulse to make the prop more efficient. And I don't think you'll ever hear anybody else talk about it. Now remember my asymmetrical prop, this is the 8-bladed version, and now we're going to look at the 9-bladed version. Remember the Osprey, okay? And so each one of these divisions right here does that. We call that the SOS prop, and the reason is when you're listening to it, it goes dit dit da dit dit da dit dit da. Okay, and but anyway, it was nicknamed the SOS prop. I'm having a Mandela effect that I remember. You could look at it and go, "That's the SOS prop." Anyway, that's the SOS prop. Observing it and showing you, it shouldn't sound like that, but it does when it's actually running. Okay, and you'll notice that with propeller design that you'll see this configuration start showing up as more and more people get familiar with what it is and the advantages. There are proposals out there to work just like the Japanese fan, where they fan out. There's technology that you can use it for torque, where it's torque consuming, but it has more thrust lift, and finding that difference, because when you add more blades, you're adding more kW to the system. And to me, kW is torque. If you have the torque, you can do anything. Okay, the horsepower is a misnomer where you're lifting 500 pounds a foot a second. Okay, and that calculates to about 750, just under 750 watts. I always just kept 750 watts in mind. But the propulsion system configuration, there's 36 units, okay, front back. You got 12 on this side, 12 on that side, so you have 24 in the back, 6 here, 12 in the front, a total of 36 9.5 kW mogens, totaling 400 horsepower in production when they're wound up at full capacity of 24,061 RPM. Okay, and we would call that 120% power, 130% power. We actually designed the system to run about 14,400 CFM. I mean, 14,400 RPM. So that's the mid range that we design at to do it. So if you have each pulse ramjet doing 44 pounds of maximum static thrust, that's 1.5 tons that you can lift, okay, in the air. Now there's different configurations that happen with that, and again, we are taking advantage of the Coanda effect in several ways, okay. And anytime that you can make a system lighter, stronger, faster, that's what we're doing. Okay. Now, the whole trick, and one of the reasons I didn't get so interested in this is because we did not, when this was proposed, the technology wasn't available for fly-by-wire like it is now. You could get fly-by-wire, but it was very expensive, and we're just getting better components. One of the things in the boating industry that was really cool was the trolling motors that you operated with your cell phone. So you could pull up to the dock, drop your boat in the water, tell your boat that you had a spot in the lake that you wanted to stay, and it would stay out there and hold that course, and then go park your truck and trailer, or car and trailer, come back down the dock and recall it with your cell phone. And that's when we started really getting things to where it fits into aviation as well. And more technologies are coming together, so fly-by-wire is going to be a new stuff. An old guy like me, I like to have positive controls. Okay, fly-by-wire, even though in the other stuff we've been doing it for a long time, is not something that I like. But the thing is that you can make it lighter with fly-by-wire. You don't have the controls going through there, rods and other things. So we can articulate a unit much more efficient if we go with the fly-by-wire system. And now we have enough computer knowledge and skills of how to program and know exactly what we're doing, and we can float the whole thing. So once the parameters are understood, the guys that do that, I'm not one of those guys, but the guys that do that can do it, and you can have confidence in it after testing, experimental. Working through it. The Osprey, I didn't really talk about it very much, but the Osprey, if you're looking at it from the top, the blades clockwise, counterclockwise on this time. Okay, the clockwise, counterclockwise. Okay, so in each one of the nacelle packages, we're not going to have one run one direction, one run the other direction. Set of nacelles are going to be running the same direction. Now you have other things that you're dealing with, rotation, gyroscopic effect, and the fly-by-wire system, but you can control each one of those to where you don't need the control surfaces of, say, rudders. Okay, all that can be handled through the power system for your pitch, roll, and yaw. So a lot less things to control. I hope you enjoyed the presentation. Hope you're having fun, because we are. Hope you had a good break. And Happy New Year, everybody. Second day of the new year, and we'll see you next trip.